Hi, today we're covering 5.8 which is linear versus nonlinear functions. So let's start off by defining the linear function. It is a function that creates a straight line a function with a constant slope. And then a nonlinear function it is a function that does not create a straight line, often graphed as a curve. So that's when looking at it from a graph's perspective. All right, let's look at a couple of examples. All right, so we're determining whether each graph represents a linear or non-linear function. And I've got a brown that's not wanting to work. So that one will go the wayside to the trash. All right, so number one, when I look at it, is it a straight line? Number one, it is not a straight line. So this is classified as non-linear because not straight line. Again, this is for your notes purposes that you write the reasoning down. So write everything that I write down. When you're answering the other questions, you do not have to explain. We're taking notes right now. For number two, it is a straight line. So therefore, this is linear because is a straight line. Can't use that green, doesn't show up. Okay, moving along. Equations of linear functions are or can be written in slope-intercept form, which is y equals mx plus b. Both the x and the y variables have an exponent of 1. It's not showing up to the best. Exponent of 1. All right, let's look at a couple of examples. Number 6. First off, there's an exponent of 2. So I know right off, because it cannot have an exponent that's bigger than 1, it has to have an exponent of 1. This is non-linear because of exponent of 2. Next example. Well, number 7. It's not in a form that looks like slope-intercept form, so that means I need to rearrange it. So I'm going to solve for y, subtract the 2x, and I get y equals negative 2x minus 5, which this is in the form of y equals mx plus b. That's correct. So this is linear. I'll box the answers. These up here should have boxed these answers. We always box our answers. Okay, last one. Number 8. Well, it's got an x and a y in it, but it's multiplying. So therefore, it is not in the form of y equals mx plus b. So this is classified as non-linear because not in y equals mx plus b form. Okay, next page. Looking at number 18. It says, we're asking if it's a linear function and explain why or why not. Is x equals 6 a linear function? Well, x equals 6, if I think about it, well, what does that graph look like? There's my coordinate grid. X equals 6 is gonna be a vertical line at 6. Well, it's a straight line, so therefore this is linear, but is it a function? Remember, it's got to pass the vertical line test for it to be a function. So this is linear, but not a function because does not pass the vertical line test. Next example. For these, we're given a table of values and we're wanting to check to make sure the variables increase or decrease at the same rate. So we've got to work some examples first. Okay, so looking at, my y values, I'm going up 3 when I go up 1, up 3, up 1, up 3, or add 3, add 1. So therefore, it's staying the same. As I change my y values, they're staying the same. And the x values stay the same each time I change. So that's why it is considered linear. Looking at the nonlinear. Okay, as my y value adds 3, my x value adds 2. As my y value adds 5, my x value adds 1. Wait a minute. That's completely different. I would think maybe if this were 6 and 4, it would be consistent because then I could simplify to the same thing. But that's completely different right there. And then here, I'm adding 7 when I'm adding 3. So therefore, this is completely not the same rate. So this is nonlinear because not same rate, which that rate would be written as 3 over 2, 5 over 1, 7 over 3, because it's always the change in y over the change in x, which really you're finding the slope. Okay, so let's look at number 19. Okay, remember, it's always the change in y over the change in x. So therefore, I start here. So it's, I'm going down. So this is subtract 1 when I am adding 4. Subtract 1, add 4. Subtract 1, add 4. So therefore, my rate of change for this is all 4 over 1, and it's the same. So this is linear because same rate. Okay, 20. We're subtracting 1, adding 1. Ooh, now we're adding 1, and we're adding 1. We're adding 3, and we're adding 1. So therefore, excuse me, this rate of change is negative 1 over 1, 1 over 1, and 3 over 1. These are not the same, so therefore this is non-linear. Now remember, you have to show me this type of work. You don't necessarily have to write the explanation. Okay, you will finish these problems. Have a great day.